Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This video is part 4 for TensorFlow and Keras basics. I am creating digits classification project in Python. Let's continue. Okay, so I told in previous sessions this Keras sequential, how you use the layers. So this was the input layer, hidden layer, output layer, and told you about these things in previous session. Now the part comes when we compile the model, how we compile the model and what are the technical terms and how to use these things. I will tell you step by step. I will again show you the output of the project. What happens is when I run this project, so this is what dataset contains, handwritten digits. This is what dataset contains, and it will predict the detected digits. When I close this, it will train the model. So you can see it is training the model in 10 passes. I will tell you each and everything what this means and accuracy loss etc. So this is the output. It is training the machine learning model. So this chart will show you the accuracy or loss. I will tell you how to read this chart, and then in the final output it predicted 7 and the true value was 7. So this is what it is. I will tell you how to read the output step by step and what everything means. So to compile the model, this is how you compile the model. Okay, so what this code means is the Adam optimizer is an algorithm that helps a neural network learn by adjusting the model's weight during training. So I told you it will automatically reconfigure the things inside, so you don't have to do this thing manually. There are already algorithms available. So one of the algorithm available is Adam to reconfigure the weights during training. It improves the learning process by using two key techniques. So first is momentum. It remembers the direction it's been moving in, so it can continue in that direction without getting stuck or bouncing around too much. So what momentum is, so when it is doing things, it will be moving in some direction and it will continue to move in the direction without any problem. In simple words, this is what momentum means. And the second part is adaptive learning rate. It adjusts how fast or slow the network learns for each parameter. So you can control even the speed based on how much error is happening. So it will check if there is error, then it can adjust the speed. This means it can make bigger adjustment where needed and smaller adjustment where things are already working well. So as I told you, you don't have to make things from ground up or scratch. All things are already available in the libraries. You just have to remember the concept where to use which kind of technique. So where can this be used? So training deep neural networks, it is popular because it often works well with the little need of tuning. So if you want less tuning, less headache, then you can go for this optimizer, Adam optimizer. Then comes this part, loss. What this means is sparse categorical cross entropy is a loss function used when you have multiple classes to predict. So again I will tell you some things. So as you know, we are detecting the digits in this project. So digits are from 0 to 9. So we have 10 classes. So 0, 1, 2 like this. So we have total from 0 to 9, 10 classes. So when you are dealing with multiple classes to predict and your labels are represented as numbers, so we are dealing with numbers, right? So when this is the situation, then you can use this loss function. Again, why to use it? It helps the neural network learn by comparing the model's prediction with the actual class. If the model predicts the wrong class with high confidence, it gets penalized more. So remember this word, penalized. So what is happening is, if it so while training, if it gives wrong output internally, then it will be penalized. Why? So it learns to make better prediction over time. So as you know, this is uh, these algorithms work just like human brain. So when we look at some idea, so we look at the pros and cons of all the ideas. So if some idea is wrong, we switch to another one. So this is how human brain works. Similarly, they have created the algorithms that works in machine also. So this algorithm, what it do is, what it does is, they do the simple exact same thing as a human brain. So why it is called sparse? Because you don't need to convert the labels into a more complicated format. You can use the simple class numbers directly. Look at this one. You can pass the numbers directly, class numbers directly. So this is the reason sparse, you should use this. If you are working with the numbers, then you can go for this loss function. So while compiling the model, you have to specify the optimizer, loss function, then comes the metrics. So accuracy is a metric used to measure how well a model is performing by checking the percentage of correct prediction. It helps you monitor how well your model is learning during training and how well it is performing while evaluated on new data. So what we are going for while compiling the model or making the model is accuracy. We want our model to be accurate. So using this optimizer, loss function and this matrix, when you pass these arguments to model.compile, what it will do is start compiling the model. Okay, so you will ask me question, what is accuracy? So accuracy is the ratio of correct prediction to the total number of prediction. So if you are making 100 predictions, so how many predictions are you getting correct? This is what accuracy is. So ratio of this. If the model makes a correct prediction, it counts. So when the correct prediction, it counts as hit. If incorrect prediction, counts as miss. This is what will happen, hit and miss in the accuracy. So again, in more simple words, if your model predicts 8 out of 10 images correctly, its accuracy is 80%. Accuracy is a quick way to see how well your model is doing, both while it's training and when you evaluate on test data. So I told you these arguments, what they means and how they works while compiling the model. Now if you have any question regarding this, you can ask. Just remember, the code is less, but you have to remember the concepts when you create or find some problem in the real world. You just have to remember what you did in this in these sessions. Just remember the concepts and you will be able to write the code easily. Okay, so if you don't have any doubt, I will tell you how to train the model. So if you can see this kind of output, what this means is, I will tell you step by step how to read this output. Very important. I have included everything in the article. You can see and read. So the thing is, so the training the model, this will be the code model.fit train images, train labels, epochs, validation split. I will tell you what each variable means and why you need them. So train images, train labels, the training data and corresponding labels. So we have training data in MNIST dataset that we are using. So what we are doing is, to train the model, we are giving the data, training data. And if you look for the code, if you look at the code, so if you remember in the previous session I told you how I'm getting the trained images from the MNIST dataset like this, and dividing by 255 in previous session I told you. So these are the train images and train labels that I am passing here, and then comes the epochs. So let's see, number of times the model will iterate over the entire training dataset. This is what it means. It will run 10 times. It will run 10 times. Number of times the model will iterate over the entire training dataset. So with the dataset, it will again and again run the dataset 10 times. So you have to control this using this. Okay. So what this means is 10 times it will iterate through the dataset. So these are the 10 times. Look at this, 10 times. Validation split 0.1. What this means is 10% of the training data will be used for validation. 10% of the training data, total training data we have, 10% of it will be used for validation. And as you know what validation is, for rechecking. This kind of output you are showing, you are seeing in this terminal, this kind of output. I will tell you how to read this. Let's see. Epoch refers to one complete pass through the entire training dataset. In your case, the model is being trained for 10 epochs, meaning it will go through the training data 10 times. Output shows details of each epoch, starting with epoch 1 by 10, the first pass through the data, and ending with epoch 10 out of 10, the last pass. So as you can see, starting from 1 and going to 10. So 10 times the complete data set. Now let's see more what this means is. So let's see. Okay, so here in this output you can see 54,000 by 54,000. What it means is, this shows that the training dataset contains 54,000 samples, and it confirms that all samples were processed during this epoch. And of course this is the progress bar. So here if I see, this is showing 1688 by 1688. So how to read this? This shows that training dataset contains 1688 sample 1688 samples, and it confirms that all samples were processed during epoch. This is how you read it. Then comes the part of timing. Let's see, 6S 3ms step. So you can see all these things. What it means is, in this output, if you look at this output, 4S75 US or sample. So how to read this? The time it takes to complete the epoch is displayed. For example, in epoch 1 by 10 or first pass, it took 4 seconds. It took 4 seconds to process the entire data set. It took 4 seconds. with average processing time of 75 microseconds per sample. 75 microseconds per sample it took, and total time taken for the uh, iterating through the entire data set, it took 4 seconds. This is how you read it. So you can see the different timings here. I think yes, 6 second for 3 ms per step, then comes the 5 second, 4 second, 5 second. So each time it is taking uh, different time. So in each pass, in each epoch, it is taking different time, that you can see here. Then you will see the loss and accuracy. Now how to read these things, so the loss, this is the error the model is making during training. It's the value the model tries to minimize as it learns. A lower loss means better performance. So what you will be looking at is lower training loss. Look for lower loss. So this value should be low. As you can see, it is giving loss each time when it runs. So you have to look for the less training loss. Okay. So let's see the accuracy, what it means. Let's see what it is giving. Accuracy 0.9928, for example, this. So what it means is, this is how often the model is making correct predictions during training. For example, after the first epoch, the model had an accuracy of 91.25%. So this is how you read it, 0.9125. What it means is 91.25% accuracy. So this is 99.28% accuracy. This is how you read it. You will see two more things here, well accuracy and well loss. What they mean is, this is the loss on the validation set. So this means is data not used during training but used to check the model's performance. So not used for training but to check the model performance. So a lower validation loss means the model generalized better to new data. So what this means is, you have to look for low value for this. So if you are getting high values, then you have to clean up things and retrain the model. You have to look for less well underscore loss, and I will also tell you when you should be satisfied that your model is working fine. I have included the code and charts also below, so don't worry. I will tell you when when you should retrain the model or change the algorithm. I will tell you the situation. I will continue this session in next video. See you in next video. Have a nice day.